Good morning, everybody, and let me thank you first for attending. I'm going to go ahead and show my screen and start the presentation and get into this. I hope you find this technology as exciting as I do, as my lab does. It's really brought a lot to the table for us, and I'm really excited to share that with you this morning. Again, pardon me, if it starts coming through poorly or I lag behind or something, maybe you can let Sarah know and then she can let me know, and so that we don't have any technical issues. Nonetheless, let's get started. I don't want to take too long here with this. I want to start with just a little bit of, what's going on with me. This is my little laboratory. Again, it's in Lakeland, Florida. We've been here since 2000. Originally, it was in my dad's dental practice, and then when he retired, he sold the building, and we built this and moved here. Of course, as you all know, no lab is anything without its people, and my people have been with me forever. Olivia and Candy are my ceramists. Olivia's been with me 26 years and is actually now my wife. Candy was my dad's dental assistant for almost 30 years. She started working for him when she was 18. Then when he retired, started working for me. This is Roxy. She has also been with me for over 20 years. She runs the lab. I laughingly refer to her as my lab Nazi. She makes sure everything runs smooth. If it's not good enough, even I get things back from her. She manages all the digital equipment, all the nesting, all the production, all the processing of everything digital in the laboratory. Sherry is my data entry girl. Package shipping and receiving. She still does the opaquing of the PFM we do, which we still do, and pretty much wears about 1 million hats around the laboratory. And then Jamie is my newest girl, although she's been there 12 or 13 years now. She obviously works in the model department, and is just absolutely fantastic. My whole crew is really amazing, and I'm sure you guys feel the same way about your people. So didn't want to take a lot of time on this. And this is our very crowded digital room, getting more crowded. When we built the lab, there was no digital. We had no, this was just a casting and finishing room originally. I will point out one thing. If you look in the back, you'll see an old Bago printer, which has now been replaced with a new printer, and we'll talk about that as we go. This is actually kind of an old picture. But if you notice, we have the digital printing area. We put it originally near this window, and that is a very bad idea, especially if sunlight can get through, because you get sunlight on a resin uncured in a tray for just 2 seconds, and it's going to mess up the resin. So if you have the opportunity not to put a printer, if you have one or will be getting one near a window, that's a really good idea. So that's the only reason I showed this, because that was a very poor idea and it messed up some of our resins. But this whole concept of 3D printing, the problem I have with webinars is that there's no way to engage directly with the audience easily. So I really don't know where you all are, whether you have 3D printers, whether you're using it, what you're looking for. My guess would be that if this webinar appealed to you, you're looking at the technology seriously. And maybe you have a printer that maybe wasn't the best choice and it's not really working for you, and you're looking maybe for something else, or to add something else that has other capabilities. But it really does, this technology really is pretty amazing, and it really does do a lot of different things. And that's what this morning's all about, is to kind of whet your appetite a little about some of the things we've found we can do with it to enhance our business and really help enhance our relationship with our clients, which it really has done a terrific job of that. Of course, everything starts with STLs. So it's really important that you be fully digital in terms of scanner and design software first, because that's really the only way to implement the possibilities of 3D printing to their fullest extent. And my assumption would be pretty much most everybody is in that position these days, at least with the scanner and design software. So myself, I'm a 3Shape guy, okay? I recently got a new E2 scanner, which I have to say is really incredible. It's amazing. We're seeing so much better results with everything we do in this because the scanner is just so much more accurate than the old 700. which we had before that. I'll just plug that a little bit. You know, I've tried exocad. For me, for Crown and Bridge, I really like 3Shape. So, but that's a personal thing, and not going to get into it. But obviously, you know, one of the primary things people look at with 3D printing is to be able to print models, because these days, with iOS systems becoming so popular in dental offices, we are really getting this thrown at us whether we like it or not. And you know, I have mixed feelings about the whole iOS situation. It changes my workflow a little bit. It's, you know, it's a little hard. It took us a little while to really embrace it and really get the workflow figured out in our laboratory, since we're mostly analog still today. But we have a couple doctors doing it, and it's got its perks. It definitely makes their preps better. I think that the key to this is really not so much what it does for us, but what it does for the doctors in allowing them to get feedback on their preps to where, you know, you don't have a lack of room anymore. You don't have parallelism issues anymore on bridges. You don't have that, because they get the feedback from their systems, and it really helps us a lot. Partial denture frames. Now, I'm a Crown and Bridge lab. I really never got involved in partial dentures. I design, you know, fixed removable cases, and I do the fixed portion of that, you know, for the, you know, planning for the rests and the clasps and the guide planes and all that stuff, but really never got involved in this part of the industry, nor in dentures. But as this technology is evolving, it's putting these kinds of things in our laps. I can easily see a time when we will be doing more frameworks. I'm already looking into this, because that is a huge market. Like I said, I do a lot of fixed removable still, even in this world of implants. And with this technology, it opens it up to all of us to be able to do. Now, when it first came along, it was very problematic. It was very hard to get a resin print, to cure it, and to not have it warp and distort, and it was necessary to still cast frames on refractory models. Today, particularly with this resin from Whitmix, their Vericast resin, people are able to print frames, cure them, and then sprue them in air, like not on a refractory model, and cast them with consistently accurate results. It's really quite exciting. The technology has come from where this hardly didn't work at all to where it's very predictable in probably about 3 or 4 years. Again, opens up to everybody. Surgical guides, of course, are something that a lot of people are talking about. I bought into this years ago, bought some software to do the fully guided surgical guides with the cone beam scans and the whole thing, and have, oddly enough, met some resistance from my clients. They kind of balk at maybe the cost, the expense of getting the cone beam, the time involved for their patients, and I really can't quite put my finger on it. But what I have found is that we discovered what I call the basic guide. And I'll show you this in more detail later, which is really just a diagnostic with holes in it. It's old school, right? It's what we used to do with denture teeth and suck downs on models. Then we put a hole in the suck down and sort of give the doctor an idea where he could go, but there was really no guidance. This is a little better, and it does two things. It allows us to put it in the mouth and check our aesthetic idea or proposal for the teeth. We can actually see it, and then the surgeon can use it for surgeries. And I'll show you the kind of results we're getting with this. It's actually kind of remarkable. And then, of course, custom trace and orthotics. These things are all possible with 3D printers and digital design, and can potentially offer avenues of revenue in our labs that we're not really maybe realizing today. And another thing I'll get into as we go along is the way that digital and the ability to do things both diagnostically and functionally in our design software and then produce them in the lab really is allowing us to capture a lot more business from our doctors and to embrace them in a way that we're becoming like a really indispensable asset for them and make them really, I guess, consider us a partner more than just the lab to which they send their impressions. And I'll get a little more into that, but I think that's very important to look at maybe capturing more of our current clients' business as a route to growth or stability than always seeking just new clients, which can be difficult. But for PFM impressibles, and I don't know about you guys, but we still do a fair amount of PFM. I think it's a fantastic restoration done properly. I know the technology is fairly bulletproof. We don't have any issues with it down the road. It has everything we're looking for, but it's metal, and we all know that argument, metal-free versus metal-containing restorations, and so I won't get into that. But I do think it was maybe abandoned a little bit too soon in our industry, but nonetheless, we still use it in the right places. But for PFM and for especially bridges and frames, the digital printing technology is unbelievably stellar. The accuracy of the fits, the fineness of the margins, and if you are digital and you're not doing this yet and you start doing it, keep in mind that because this is being produced in layers with a very high resolution in a printer, you can make your margin offsets and the thinness of your margins down to well under 0.1, 0.08, 0.05. You can create really, really fine margins that you can't do if you're milling, because the materials and technology really doesn't support that, which I'm sure you probably know. And as far as long span goes, I've never seen anything like it. The ability to produce fits on bridges, on frames like this. And one thing we've also discovered is that, there was always a shot in the dark, a crapshoot when you were trying to cast long frameworks and have them fit. That whole variable is going out the window since we've been able to do this in one piece digitally rather than having separate pieces that as we used to do, and hook together the wax to try to then sprue and invest it and cast it. That was the source of a lot of warpage and errors. And of course, the materials today, are not all this good. Okay, not all resins will burn out and cast this clean. That's something else that you have to look at in terms of resin selection and resin developments. And all companies are not the same. These resins that these were cast from are the Whip Mix Vericast, which is a really excellent resin for casting. Again, the kind of fit that you get with the bridges and then with the castings is absolutely stellar, and all the variables are kind of off the table now. Even on implants, where we do a lot of restorations, the problem with waxes, as everybody knows, on metal is the shrinkage and then the distortion at margins. Very hard to get a really fine margin without using softer waxes or whatever, and all those issues are now gone when it comes to PFMs on titanium abutments, which we still do quite a few in the right situations. Again, I think technology is one of those things where it's up to us to really understand the implications and the personality of all our different options and technologies that we have available for making restorations and producing cases. And we should always look at using really what we feel is the best approach to any given situation. So having a variety in our hands is really, really exciting. But this topic about value-added services is one of the big things that really popped out at me and with our lab and our relation to our clients when we started going digital, particularly with digital printing in our hands. And I'm going to pop back to that basic surgical guide idea and kind of show you what I mean here. I'm sure you get it, right? I mean, this was a case where we had pre-existing teeth that were going to be extracted, and I simply marked I ground them off and marked the center of the teeth where the root channel was. So I because this is where some of the implants were going to go, and I wanted to mark this spot so I could see it when I was doing my diagnostics to maybe coordinate a little bit our aesthetic proposal for this case with where the roots are currently. Again, these were to be extracted. So anyway, just typical modeling in 3-shape. produced that, and then used those guys to kind of help me with my teeth and to put the holes in the restorations at the sites where the doctor had told me the surgeon was planning on doing it. And sometimes we'll put in a few extras in case the site isn't right, because again, this is not guided surgery. This is not using a cone beam. This is not using a scan of the bone to really do this. It's really a placement guide. And like I said, I'm amazed that this is really getting traction as opposed to fully guided guides, which I honestly don't understand. But this one we produced in an orange plastic. Okay, we could produce them in a white plastic. We could use them for diagnostics, for aesthetic proposal analysis, those kinds of things. My question is, I wish we had a material that was radio opaque, because this also can be put in the mouth when the cone beam is taken, if the surgeon does that. And to produce a ghost image of this, like this, it would have to be sprayed with a barium spray, which can be done. And we have a few clients whose surgeons are doing this, putting this in the mouth, checking out the aesthetics of it, because it is full contour, and then it'll appear in the cone beam. It can help guide them to which sites are better if they do their own design. Okay, if I do it, I'm going to try to do fully guided. But again, it's crazy how little traction I seem to get on that. But I wanted to show you was I put this on the actual model of the implants that we got when the case was finally done. I drew around the teeth, and this is really good. Okay, the implants are in exactly the right places. And with this really simple thing, and the cost is low. I mean, sometimes I will give them that basic guide. I mean, I'll charge for the diagnostics, right? Like a diagnostic wax up. But in digital, okay, now I've done that. I've got something, a mock-up I can try in the mouth and check my incised ledge and check my aesthetic proposal. I've got something that can go to the surgeon and help him put the implants in a better place. I then can come back when I get the case, and I can reuse all that modeling in the next step of the case. And if those skills are something you don't have, how do you dig into your system and use old modeling and reuse it as the case progresses from diagnostics through the actual production of the restorations, whether it's PFM or all ceramic or zirconia or a combination, then that's something that I also can address at a later time if you guys are interested. But we're seeing this kind of results over and over again with just this basic guide approach. So this same case, when we got the impression, the transfer posts, it was not digital. The transfer posts were a little bit wobbly. I called the doctor. I said, look, I'm unsure about the position of these implants. We should double check this. And I said, I want to send you a placement guide and maybe give me some pictures now that we're at this stage. And so all I did was remodel that original diagnostics on top. I scanned the actual abutments, just aligned it in the 3 shape and readapted that exact same modeling to those implants now, printed this, which is, trust me, way better than milling PMMA, and sent this to the doc. This did a couple things for us. When it got to the mouth, I could get some photos of, it's not really beautiful. It wasn't meant to be, but at least I have some idea of the size of the position, basic parameters of the bridge, and was it any good? I asked her to take pictures, and what I got was really crummy pictures and really nothing showing the patient's smile. But this is the idea in the mouth, and it did 2 things. It confirmed our incisal length for the patient, and it confirmed that the abutments were for sure in the right place, and everything was good. Now, when it comes to implants, it's quite difficult to really get a stellar aesthetic result with implants the way they're typically done, which is no tissue training. Very few doctors really will embrace custom healing abutments for the time and the cost. Typically, we get a model with a hole in it like this, and usually a tiny hole for a bigger tooth. like this restoration here for this central. And so it becomes imperative that we understand how to manage our tissue accurately and predictably so we get the best emergence and the best results, yet not violate the ability of the tissue to really respond to what we're doing. And so what we do pretty much in every case is start any implant with some quick diagnostics. And again, the key to all this is reusing it. I don't want to design a tooth more than once. I don't want to do it. What I want to do is design it once, then use that multiple times for the different things I may need to do in a case. And so I'll produce that little diagnostic, which goes down in the hole for the implant and lays on the tissue as it was before anything was done. Print that real quick. Doesn't take long. I'll print them horizontally. I sprue the facial surface and print them low because that's very, very fast. If you pin the incisal edge and print this whole length, it'll take about 3 times as long. So I can print this horizontally in probably about 15 minutes, okay? And I'll set my printer to a high Z resolution, like 100 microns, so it picks really thick layers, because I'm not interested in total accuracy. I just want something where I can see where I would like this tooth to come out of the tissue and what kind of emergence I would like to have ideally. As far as when I mentioned Z resolution and being able to change that in a printer, that's really important, and that is the kind of stuff we're going to talk about in the next installment of this continuum, this 2-part series. Talk more about that. Anyway, what this does is show me exactly where I want my tissue to be, and I can look at what I've got, and with a little bit of experience and knowledge, you will understand. It's easy to predict what this tissue is going to do. Again, this is another topic on how to really do this and not end up with an exposed margin by maybe violating the characteristics of the tissue and trying to push it in a way that's not going to happen in the mouth. You really don't want to create a situation where the doc is going to be having to do incisions or a laser surge or radio surge if possible. But the rules are really pretty easy. Again, though, every time I do this, I see an outline that is not what I would have drawn if I had just guessed at what the shape of a tooth is supposed to be with an emergence. It's always different. Nonetheless, I will modify the tissue based on the diagnostics, then make the tissue mask on that modified tissue, and then produce the abutment of the restoration. And you can see here that we have extremely conservative margin placement. Okay, I'll digress a tiny bit. This whole thing about screw-mentable crowns, and retained cement causing failures of implants, which is very true. It's the primary leading cause of implant failure is cement way down in there. But the leading contributor to this is subgingival margins. And most abutment designs that I see put margins like 1.5 to more millimeters subgingival because everybody is so terrified of showing a margin, particularly if they're titanium. And so the answer to that is now, not to get better at designing our abutments, but let's make everything screw retained or screw mentable so the doc can, fill in the abutments, cement on the crown, take out the screw, take out the assembly, clean it up and put it back in. And, there's a whole lot of things that can go wrong with that as well. Yes, it's retrievable. Yes, I get the whole idea, but I think a lot of the motivation comes from the inability to predictably place margins where we want them. So this is that abutment in the mouth. Again, you can see extremely conservative margin placement. This is an Emax hybrid, which I don't do anymore. I do all zirconia hybrids these days. And then this is the crown. Unfortunately, crummy picture from a doc. And I don't want to go into case after case, but I will tell you that this approach is giving us results that are blowing me away. We are being able to place margins at most 0.5 sub G, predict where the tissue is going to go, have it contoured properly for the tooth that's going to be put there, all because we have a printer and we have a way to do diagnostics before we start the abutment and crown design. Here's another application of the printer, which is really, really nice. We can do these things without this technology, but I don't think as well. Here's a case, 2 implants, 6 and 11, and the doc wants ovate pontics. And that's always kind of a crapshoot on how do I modify this tissue exactly how I need it to give me really nice emergence on both the ovate pontics here and this tissue here. Well, you already know we're going to do the tissue on the implants like we just described. So when I produce the modeling for this in the 3 shape, I go ahead and bullet nose my pontics from underneath about the way I want them to look. And with I can do a 2D cross section, look how far into the tissue they are. But this gives me a really good visual. I got to tell you, I love digital. It gives me a really good visual of where I want to go with this. Well, then I just print this thing up. Okay, and then with some indicator, we use lipstick. Just put a hole in a lipstick cap and use one of those little applicators to apply it. Good trick, by the way. And just start using this to help guide my tissue contouring. Okay, so now I produce ovates or sockets that really are based on something real, which is the diagnostics I did. And of course, we'll do the same thing with the abutments and the tissue and see where I've got to go and kind of what kind of profile I need here without going too much into this at this point. And that would be really the final proposal for this. Then, of course, this modeling will be reused to actually produce the frameworks and then make the castings and then make the final restorations, right? Which I don't have a picture of. But nonetheless, then there's this application. Normally, the doctors don't know this. They will send me a case for a diagnostic, and in the process of doing it, it becomes really obvious that we need to do some crown lengthening here. And so when I send this picture to the doc or email it to him, it's like, it's a no-brainer. Yeah, doc, we got to do this, you know. But I'm going to provide you with a guide here that you can either use yourself or send to the periodontist so that they can accurately know where we need this tissue moved to in order to produce this case. They can actually, we print this, we actually, the surgeon puts it on the teeth and has an exact line of where they want to go, okay, to recontour the tissue very accurately based on our diagnostics. This case is just an example of that. I got this case to do a diagnostic proposal for, and we almost always do mock-ups, which means, yes, I will produce this in white wax to make an actual study model that's shiny and pretty like we always did that we'll duplicate and send along, but I'll quite often make a mock-up if it's an additive case that could be used chairside, and I'll show you that in a little bit, and this is huge. So when we did this case, and you know, we just took a look at how much, this is the picture I sent the doc, look doc, we're going to want to do this with the tissue in order to accomplish what we're looking for. And, you know, okay, so I just print that up, send it to him, goes to the surgeon, slam dunk, done, okay? But as far as case presentation mock-ups go, I think this probably in itself is the single biggest thing that this whole approach to digital and diagnostics and printing and services and value added and all of that to the doctors, this is probably the single biggest thing we do. And I think our large case acceptance rate has gone from probably 85% to 99% because of this. And it allows me to partner with my doctors, right? And help them sell cases, because trust me, they sell a case, I get the case. And I help them do that for free because it's nothing to me to do this. It's so easy. They just, you know, it just blows them away when you do this. I'm going to start with this little case, which it was really just a young patient, you know, wants to fix his teeth, doesn't like his smile, right? Okay, it's obvious what needs to be done with lengthening these teeth quite a bit if we really want an ideal curve. We do the diagnostics, we produce the STLs, and luckily when we have a case like this that's additive, it's a total slam dunk because this can be tried in the mouth without any prepping, right? And it's way quicker for the doctor to do this than try to do a suck down and do a mock-up and cure that and clean it all chairside. If I give him this, they just love it. You know, at first they said, well, I can do that pretty quick. And I said, oh, really? Well, how quick? Well, I don't know, probably take me 15, 20 minutes. I said, all right. So if your overhead's running at $800 an hour and that takes you 20 minutes, you just dropped $250 on doing this for the patient for free, right? And their jaw drops. Okay, I'll give you this, doctor. I'll give you this with the diagnostic. Okay. Now in this case, this was wax. This was before we got our printer, and the drawback here was that now we print these for the doctors, for the clients, and they give them to the patient. Say, hey, take this home, slip it on. You know, don't eat with it, but show it to your spouse or your significant other or your friends at work or whatever, right? And ask what they think. Right? You know, how do they like your new idea? We get feedback on length. We get feedback on lip position. I see this and I'm thinking, it might be a little long. Not sure. Maybe we need to send this back to the cuspids, whatever. You know, just get a lot of feedback from the photos that he'll take, you know, and, you know, this I think turned out to be a camera angle issue, which is a whole nother topic when he took the clinicals, because the reality is the mock-up really didn't have the kind of length relative to the laterals that we see here. But another topic. This case was absolute killer. This lady didn't have a lot of money, has always hated her smile. It's easy to see why. It's really funky, okay, a real sway back smile. So we did the exact same thing. Just did some digital diagnostics, printed it. It's not pretty when it's like this. But when the doctor brought her in for the case presentation, and he didn't, you know, just show her a shiny model on an articulator, which, trust me, a patient, there is no connection between looking at a model in air or on a machine that looks scary to seeing them in your face, okay? And again, like I say, I'll give them this. It's fine, because I want this patient to buy this case. He put this in her mouth, and I got a phone call while she was in the chair telling me that she was crying. She was so happy, okay? And not only that, look at this. You know, home run, perfect aesthetic proposal. I mean, we fixed all this back here. Whoa, and we did all this additively. No preps, no nothing. She took it home, showed her husband. She was in the chair the next week getting a huge case done. And now her husband's getting his mouth done. This is so invaluable what you can do with this. And even the doctor can even adjust this, right, if necessary, because we're going to bring vertical, we're going to raise vertical just a hair, and actually give us something that we can help get the proper occlusion when we articulate the case. It brings a lot of things to the table for us. In, again, partnering with our clients, becoming their indispensable asset, and helping them sell cases for free, okay? It's so easy to do. Transfer bases. This is something I was shocked to find out that people kind of forgotten about a little bit. This was for a relatively newer client, a little bit newer client, that had a problem getting a bite back here, had no ridges, terrible case. He tried taking a big blob of blue mousse, and that just never works out very well. What you want is what we call a transfer base, which is just the appliance that fits in the mouth and take a bite against to fill the space. It's a very simple concept. Now, in 3Shape, I don't own the module to do this. I didn't buy it. So I just basically do this in a real simple way. Line up a bunch of teeth, just goosh them in there, smooth them up, right, and produce this. It takes me almost no time to do. All I got to do is make sure I'm in infra-occlusion, that I have some room for the dog to put some bite in here. What's also nice is that the small amount of morphology makes for great indexes of the bite. It makes positioning it real easy, much better than a bite block that's just flat with a few little grooves in it, which they're okay, but this is just happens, so it's really nice. Then I print this, okay, at the printer, and deliver it to the doctor. He took the bites on this, fit the patient's mouth very well, and now we have a way to mount a tricky case very accurately. So it was an easy way to solve a problem utilizing these technologies. Okay, and so, you know, all of this really comes down to the fact that when we're looking at today's climate, in the business climate, the downward pressure on on everything we do. It's getting tougher and tougher and tougher. And it's not easy thing to always try to get new clients and try to get new things. I really believe in enhancing and growing our relationships with our existing clients. That's really what I like to do, and that's really where I've found a lot of success. And leveraging digital technology and leveraging prototyping technologies, in this case, the printer. Yes, we have a mill, and yes, you can mill these things too, but hey, milling wax doesn't cut it. Milling PMMA is just horrible, and it tears up your tools, and it's expensive. I mean, this technology fills a gap that we couldn't fill before. Okay, with trying to do these things for our clients. And one of the things that happened to us recently was I got a call from a local client that had a situation with some real labor inclined lower incisors that he couldn't get an impression on. It kept breaking when he was trying to do it. We tried pouring it, we couldn't do it, and he needed a custom tray, but he had to get it done right away. So we pulled out the triad, we got the model, we got the base plate wax, started putting the base plate wax on the model, and pulling warming up the triad because it's stiff from being in the fridge, and we had used it a long time, and it's starting to make a custom tray, which when you get down to it takes probably 20 to 30 minutes to actually do it. It's time consuming. And all of a sudden I went, hey, wait a minute, right? We've got 3Shape. 3Shape does this, doesn't it? I had never done this. Okay, I had never done a custom tray. I don't do them a lot. I have a few clients that do them on everything. And so I just launched the module, and 3Shape will let you do a few things in modules you don't have without charging you. Like 10, you can make 10 things. You can model build 10 models. You can make 10 custom trays before all of a sudden they want CAD points or they want you to buy the module. But I had never seen this, okay? And maybe this is a little plug for 3Shape, but it was a total no-brainer. I mean, scan the model, boom, 45 seconds, right? Path of insertion, boom, done. It detected the undercuts, right? And blocked them out, okay? Tell it, how much relief do I want, okay? Draw my line around this thing, okay? And I got a tray, okay? I mean, this was probably, 3 minutes to do this? And then, on the inside, it's a very accurate tray as well as far as doing what we want it to do, keeping even impression material thicknesses and getting a very accurate model properly blocked out up here where the problem was. And we had a tray in probably 2 minutes. Now, it did take it an hour and a half to print, okay, but the actual labor time I spent 3 minutes on that at the most, and get $30 for that. Okay, I'm telling you, I'm going to start promoting custom trays. I got one client that does it all the time. But this really is the end of what I wanted to cover in part one, which was really just to whet your appetite, maybe give you some ideas for some things, maybe kind of get you thinking, not just about printers, but expanding your use of technology and kind of how can we use this in a way to really help our clients in a way that helps us. And hopefully you got some ideas out of this and it whet your appetite a touch for next time, right? When we will dig into the specifics of actual 3D printing, okay? And, different types of printing, understanding parameters and specs, what they mean. A little while ago, I mentioned changing my Z-axis resolution to 100 microns when I want to print something fast, piece of cake, okay? But you need to understand these things or you're not going to get the most, or number one, you may buy the wrong printer, or number two, you may not get the most use out of it if you don't understand what they can do and what these things mean. And I want to compare and contrast some of the popular printers so you understand what's going on with those, What do they bring to the table? They are not all the same. There's quite a range of functionality and things that they will or will not do for you. So coming down to how to select the right printer, okay, and basically so you will know all the right questions to ask when you're talking to a potential supplier for a printer if you're looking, and you will get really what you need for what you want to do with it. all right, and you won't end up with something that all of a sudden doesn't fit the bill and you just dropped, all money is serious, but dropped some serious money. So that brings this webinar to a conclusion, which is about perfect. Leaving some open time if there are any questions, and letting you off the hook a little early to get your hour credit if there's not. So at this point, maybe I pass it back to Sarah. That maybe, I guess, if you guys have any questions, you can just text or chat with her a little bit and pass them along. So with that, I thank you for your attention, and I hope you all come back next time because we'll really get into some meat of the technology on the next one. Thank you.
All right, thank you, Al. At this time, I do want to open it up to questions. If you have any, you can write them in the questions box on the side of your screen. I'll probably just hold on for another maybe minute or so to see if any come in. We haven't had any yet. But again, we will be emailing information on how to obtain your CE credit later this afternoon, along with a link to the recorded webinar, so you can pass it along to anybody who you want to view it as well.
And may I suggest that people that attended this and over the next week or two, before the next part 2 of this, they may have some questions pop in their head, maybe some how-tos, maybe some something. If they, either bring them to the next one or pass them along to you in between the two, we can address them at the beginning of next time as well.
That's a great idea. So we do have one question. What about sleep apnea printing?
Pardon me?
The question is on sleep apnea printing.
Uh-huh.
Is that, I guess, something that you can do?
Oh, yeah. And something else I didn't mention is Invisalign, right? Hey, Invisalign, their patents went up. I mean, if you may notice, there's all kinds of activity now with other companies coming in doing an Invisalign type of appliances. So, there's one, I forget the name, is strictly internet-based. They'll send you an impression kit, and they will start sending you, every couple weeks the next stage in the Invisalign process for a lot less money than the docs do it. But the point is that design software and that technology is available now to labs, and we can do that. Same with the sleep apnea. Anything that you can generate an STL for, okay, it's just the right software and the right scanner. If you can generate an STL for what you want, then you can produce it and sell it and make a product out of it. Okay, I think that's brilliant. In fact, that's something that I have looked into. I have a couple of clients that are getting very big into sleep apnea, and they work with companies to produce our devices. And we've just started having conversations about perhaps us being able to do it here for them. So yeah, definitely, that's a definite thumbs up on that.
One other question that came in was, what was the white material you were printing with, and where did you get it?
Oh, okay. This kind of gets into next time, because printing resins is not just printing a resin. In other words, every resin that's out there is going to have its own kind of personality. It's going to have initiators that require a certain wavelength of light. It's going to have a viscosity that's going to require a certain duration of exposure for each layer. And if you don't expose it right and process it right, then you'll get a print fail. You'll either get layers that don't stick together, or they'll be overcured. You'll get splatter of the light. You'll get inaccurate edges. You'll get fuzzy edges. You can have a lot of problems. So one of the issues with resins that are just on the market that you may find, cheaper resins typically, because we're looking for them, is how do I actually make my printer work with that one? Which is why people typically purchase resins from the company that made the printer that they got. But this particular resin is actually from, I found it on the internet, it's from a company called FTD, which stands for Fun to Do, and it is their Snow White printing resin. It's relatively inexpensive. It's like $80 for a liter of it, okay, or a quart. I'm not sure which. I'm not sure how it comes. So it's really quite inexpensive. My problem with it was that I tried it in the printer I had at the time, which was the Bago, and it didn't work. Okay, I mean, I just could not make it work. And this is before I really understood what was going on with these printers. But that problem is now a thing of the past with some of the printers on the market now, which we'll talk about next time, which do allow you fully open printers, and there's only one or two that I know of that are fully open that will allow you to actually determine the proper exposure protocols for resins that you find out there. Now, keep in mind, though, that when you start going for third-party resins, you can run into things like FDA. You can run into things like they can have chemicals in them, like BPAs, that are kind of dangerous. You don't really know, okay? So you have to be a little bit careful when you start selecting resins from just the internet out there. And, of course, printing them can be problematic too. But we will get more into that next time. Very good question.
Okay, I think that wraps up all the questions we have today. So I want to thank everybody for attending, and I hope to see you back on the 28th. And like Al said, if you had any questions, just please reach out to us. You can always email webinar@whitmix.com if you have any questions. And everybody have a great afternoon. Thank you.
Thank you.